Sorry for the delay again. Thanks, Raki, for the introduction. So, as you were mentioning, I have been working as a Chromium engineer for some time, and I'm currently coordinating the Chromium team at Igalia. And Shin has been working at Igalia for 7 years and has been working on multiple Chromium-related projects. And lately, we have been working as part of one of those efforts we are doing at Igalia in the station migration that we're going to present here. So basically, the goal of the talk is to explain what we have been doing there, the motivations we were finding, the problems we were trying to solve. And the thing is that the fact that we had been having at Igalia a big focus on open source web engine for mostly like a couple of decades over our history, we have also the perspective of things working on different web engines. We have teams that are working on WebKit or on other web engines that are more modular, so there are things that are interesting also for the Chromium team. The situation is that we were finding that in some projects that we were involved that were related to the development of Chromium-based solutions, there were some challenges related with the integration of extension support. So basically, for things that are not oriented to desktop, we were seeing that there was, like, the architecture of Chromium, it's more monolithic than other web engines in general for some of these parts. And the idea is that there's already a very interesting API, extension API, to inject functionalities or change the behavior through the current APIs. But integrating that into some existing solutions was complex. Some ad hoc approach had to be followed, and they were complex to maintain. So the thing is that we thought that it could be possible to have like a better architecture approach, which was easier to maintain, to reduce coupling with the // Chrome directory. So it could be possible also to have extension support or on other platforms that are non-desktop. We were targeting other embedded hardware platforms like Raspberry Pi, for example. It could be for iOS, for Android mobile devices, and different build targets from the whole Chromium. So it could be possible to have that integrated into other smaller components and build a Chromium-based browser on top of that using part of the functionalities coming from the extensions part. So what we did, some of the projects we were involved were related to tailoring some specific extension API support of some subset of extensions regarding a reduced part of the APIs that we're using for some web views or some other built-on content shell components. And we presented this idea of planning this support, making easier upstream in BlinkOn 20 conference, which is like the main Chromium conference, was hosted by Google in Sunnyvale, San Francisco. And then we also started this approach by generalizing its support also for Wolvik XR open source browser, which was also having extension support. Was interesting to have it there after it was presented, this approach in BlinkOn. But also, well, the work that Shin was doing was gradually moving from the change in the architecture, replacing the changes we were doing, moving the Chrome layer bits to the component layer into an extension, / extension layer after agreeing it with Devlin and other extension API owners. So we continued that work, which was also this migration during October past year. So the process has been continuing, and yeah, this ongoing work is now able to be functional, and Shin will do a small demo of the status that we can already test and use right now out of the box. This is also compatible with other initiatives that are happening upstream on the Chromium code base. There's also the ongoing effort of Android for desktop or Aluminium that it can also use part of this approach that we are following. So yeah, in order to know a bit more like about the technical details, the changes that we have been doing, I think I can add it over to you, Shin. So okay. Yeah.
So since the migration effort began in September last year, we have rendered 48 patches with 2 patches currently under the review, and migrated over 100 files from the Chrome layer to extension layer, and refactored or relocated related code to reduce and remove Chrome dependencies. So what has improved? One major milestone is that we've successfully migrated support for all extension installation format. CRX is the standard format used by Chrome Store. Unpacked extensions are primarily used during development and debugging. And zip packages are commonly used for internal distribution and package deployments. Supporting all these formats was one of our certain goals, and I'm happy to say that this work has been completed. This is an important step toward making extension truly embeddable, as application can now support extension installation without pulling in large portion of the Chrome layer. So let's see the demo video. Maybe. Just okay. Yeah. Okay. Before starting the demo, I have prepared the previous version of Fcell with the extension support enabled. To make extension installation and execution possible, I implemented the minimal embedded side functionality required by the extension framework. So in this demo, I will show installation of extensions in different formats and execution of simple extension running on top of the embedder. I mean the F-shell. So run F-shell. As you can see, the UI is almost identical to default content shell UI. And the only addition is this install button. The button opens the file selector. So if CRX file is selected, it will be installed as a CRX extension. And if the zip file is selected, it will be installed as a zip extension. Any other file selection will be interpreted as an unpacked extension using its parent directory as the extension path. So, okay, let's start with the CRX package. Okay, I'll try to the good CRX first. Then, as you can see, the installation success is, and the title bar is updated with the success message. And now let's try to invalidate the CRX package. Then the installation fails and the error message is displayed in the title bar. Okay, let's try to zip format as well. Again, the installation succeeded and title show the success message and bad zip. And as expected, installation fails and error message is displayed. Okay, finally, let's install the unpacked extension. For this part, we'll not only verify that extension can be installed, but also that is actually run correctly. before installing it, let's briefly look at what this extension does. So I will try to install this unpacked extension. Let's see manifest.json file, and it has the rule, declarative that request rule. So let's open this rule. And the rule blocks is navigation to example.com when the request targets the mainframe. So let's verify the current behavior. So first, I will navigate to the extension example.com. Okay, example.com. As expected, the page loaded normally because the extension is not installed yet. So now I will install the unpacked extension. Okay. And the installation succeeded, and let's navigate to the example again. Then this time the request is blocked by the extension. This demonstrates that the extension was not only installed successfully, but it is also actively running. Yeah, teacher. Thank you. Okay. So at this point, some of you may be wondering, so can you install extensions from Chrome Web Store? And more importantly, will those extensions actually run on content shell? Many people immediately think of popular extensions such as AdBlock and expected those to heavily on Chrome UI components or Chrome specific API will require additional migration work before they can function correctly outside of Chrome. The more tightly coupled an extension is to Chrome specific functionality, the longer it will likely take before we can run it successfully in an embedded environment. That said, I expected some popular extensions such as AdBlock, uBlock, or some VPN apps to become viable much sooner. Many of them primarily depend on relatively small set of the API, and once those API are migrated, they should be able to run with a little or no modification on embedders. This brings us to next page of the project. Yes, API migration. We already complete the migration script API, and we are currently working on Web Store private API. After that, we will continue evaluating and migrating commonly used APIs such as Action, Cookie, DOM, Tabs, and others. The long-term goal is to make a broader set of the extension functionality available without requiring Chrome-specific dependencies. Ultimately, this will enable embedders not only to install extensions from Chrome Web Store, but also to run real-world commercial extensions on top of their own applications. Before wrapping up, I'd like to briefly talk about some of the challenges we've encountered during this migration effort. The first challenge is API migration complexity. Not all API are created equal. The amount of work required depends heavily on how tightly API is coupled to Chrome layer. For example, Script API had relatively few Chrome dependencies and was migrated in just a single day. In contrast, Web Store Private API has a significant depends on Chrome-specific code and UI, and migrating it has taken several months of work. Looking ahead, APIs such as Action API will be particularly challenging because they are deeply integrated with broader UI concepts that do not naturally exist in embedded environments. The second challenge is testing. Recently, all tests in extension layer has been moved into Chrome layer on top of tree of Chrome main branch. While this makes sense for Chrome development, it creates difficulties for verification on embedder side. Functionality that is intended to live in extensions can no longer be validated independently from Chrome layer. The final challenge is the demo and validation environment itself. Historically, extension shell provide a lightweight environment built on top of content shell, making it easy to experiment with the validated extension functionality outside of Chrome. However, after testing code migrated to Chrome layer, extension shell was removed from top of tree as well. As a result, we have lost convenient environment for demonstrating and validating extension support, and we now need alternative approaches for testing and demos as the migration progress. Well, we are also sharing our progress through a series of the blog posts. And if you're interested in this topic, please feel free to reach out at any time. I'd be happy to discuss the project, answer questions, or share more details about the migration effort. And if you'd like to contribute, you're more than welcome to join the migration work. Additional contributors are always appreciated, and we'd great have more people involved. Yeah, thanks.
Thank you very much, Shin and Lorenzo. Do we have questions?
So you mentioned that the tasks were basically moved from the extension directory back to Chrome. Meanwhile, you've actually moving the support, the core support, from Chrome to extensions. So they are in different directions. I wonder what kind of coordination you do with the Chrome folks, so you get, the migration work aligned with the rest of goals that Chrome has.
Yeah. Yes, unfortunately, the appears to be to the case. I only became aware of this relatively recently and have not yet the opportunity to discuss it with the extension owner. I'd like to get more background about that and whether there are plans to better support the testing code for only extension layer. And at the moment, since we And sorry. And yeah, at the moment, there seems to be mismatches between the architectural goals and moving extension functionality out of Chrome layer, our approach, and the fact that the test infrastructure has largely moved into opposite directory. But yeah, I need to some discussion with the extension owners and have some proper approaches for others. Yeah.
One more quick question. So you welcome contribution for other folks. I wonder if you have kind of a design document or so, because my understanding is that you first define leaf nodes because they have no dependencies, and then you migrate them, and then you move to the other ones where the dependencies were resolved, and then the other ones more complex. I wonder if you have defined the tree of dependencies so others can actually jump in and contribute, or if it's more in a different, I don't know, approach that you take to actually decide what is going to be moved next in terms of migrating things.
The next page is the supported as I mentioned before. Our plan is to support more migrating the APIs to use the APIs with the only extension layer, and also we need to provide the extension the testing code for how to verify the extension layer itself, and also how to we verify the extension applications with the extension share. So I'd like to propose the restore the extension share on extension layer, but if not offsetted from upstream, we have to plan to provide the reference code on in the Igalia repository, so for the others embedders.
We have time for one last question.
Hi, great presentation. So my question is, so since you're moving you're allowing Content Shell to also run the extensions, and some features that used to exist in Chrome is not available in Content. Like I believe tab support is in Chrome but not in Content. So for these kind of things, do you how should extensions declare that it can work in Content or it cannot? Like if it depends on something that is explicitly only available in Chrome, can it make a note in the manifest saying that it will only work on Chrome but not in Content?
Yeah, no, I think that's a good point. So as Shin was explaining, there are different candidate APIs to be migrated, and the problem of some of those might be like exposing if they are supported or not when it running on Content Shell, because they are, I mean, as you said, if an extension does tabs management, it would never, I mean, despite what you can implement at the API level, there are functionalities that rely on the API, on the UI. So I don't know if we have any component of that, but it should be it should be implemented as new functions that describe if the API is available when running on that specific target. So, but there are others which they are. I mean, we mentioned some of them, but the thing is that it should be supported on other more complex scenarios where you might or might have not certain UI functions. You could be running that on a web view. There are places where you could have different levels of support. So I think it's incorporating into the manifest capacity to talk to the extension to know if the APIs are available on that target or not.
Awesome, thank you.
Okay, thanks.
Thank you very much, Shin
Okay.
and Lorenzo. Great talk.